Something strange happened last week that had nothing to do with a hurricane, an earthquake, or a wildfire, and yet it pulled in a crowd most breaking news stories would envy. Nearly 6,000 people logged onto a single online town hall meeting. Not because a celebrity was speaking, not because there was breaking political news, but simply to listen to a panel of scientists explain what's coming for the California coast this winter. Think about that for a second. 6,000 people, voluntarily, on a weeknight, tuning in to hear a climate briefing. That's not normal. That's not what happens when forecasters roll out another routine seasonal outlook. That's what happens when word starts spreading that something genuinely unusual is building out in the Pacific. And people want to hear it straight from the people who study it for a living. And in this case, the instinct that pulled those 6,000 people online was correct. Federal forecasters have just confirmed a number that has never once appeared in the historical record, going back to 1950. Not close to it, never. And the scientist who has spent his entire career studying California's most extreme weather events is now using a phrase he does not use lightly. He is calling this an event the state hasn't seen in living memory. So, today, we're going to break down exactly what NOAA just confirmed about this developing super El Nino, why it's already surprising the very scientists tracking it, and what it specifically means for California this winter, from the coastline to the ocean itself. Let's start by explaining why this particular update matters so much more than the steady stream of seasonal outlooks that normally come and go without anyone outside the weather world paying much attention. Meteorologists issue updated forecasts constantly. Almost every month, there's some new outlook, some new set of odds, some new set of maps with shading that shifts a little one way or another. And most of the time, the language in those updates stays fairly measured. Likely above normal. Elevated risk. Slightly favored outcome. That's the normal rhythm of seasonal forecasting. And it's why most of these updates scroll past without much notice. This update was different. This was a federal agency's own lead scientist using the phrase "never happened in our historical record" to describe a number that isn't some minor technical footnote buried in a spreadsheet. It's the single benchmark measurement that the entire El Nino classification system is built around. When the agency responsible for the official national forecast starts describing the underlying data itself as unprecedented, that is a completely different category of update than the ones that come and go every winter without anyone blinking. Now, let's get into the actual number that's driving all of this concern, because it's exactly the kind of detail that tends to get buried under vague phrases like unusually strong, without anyone ever explaining what that actually means in practice. On August 13th, 2026, NOAA's Climate Prediction Center released an updated assessment confirming that a super El Nino is now 95% likely to develop this year, with a 7 in 10 chance that it ends up being the strongest such event ever measured since comprehensive record-keeping began back in 1950. On its own, that would already be a significant story. But the specific detail that has genuinely caught scientists' attention goes even deeper than that headline number, and it involves ocean temperatures in what's called the Niño 3, region of the tropical Pacific. This is the specific patch of ocean that researchers use as the standard measuring stick for El Nino strength. The benchmark region the entire classification system revolves around. And here's the part that should stop you in your tracks. In the entire modern historical record, going all the way back to 1950, water temperatures in that region have never exceeded 4.5 degrees Celsius above the seasonal baseline. Not during the massive 1982 to 83 event, not during 1997 to 98, the El Nino that reshaped how an entire generation of Californians thought about winter storms. Not even during 2015 to 16, the so-called Godzilla El Nino that people still talk about today. Never. NOAA's updated forecast now puts the odds at 69% that this year's event will reach or exceed that 4.5 degree threshold. A level of warming that, in the words of Michel Leroux, the El Nino team lead for NOAA's Climate Prediction Center, has simply never happened in the historical record. That is not scientific hedging. That is not cautious language designed to cover every possible outcome. That is a federal climate agency stating plainly that the ocean is doing something it has documented evidence has never occurred before. At least, not since instrumental records became reliable enough to say so with confidence. It's worth taking a moment to understand just how rare a genuine super El Nino actually is, and how each of the handful that have occurred in the modern record has left its own distinct mark on California. Because that history is exactly what makes this new forecast so unsettling to the people who study it. The 1982 to 83 event was one of the first strong El Nino events studied in real time with modern satellite monitoring, and it brought severe storms and flooding across California that caused billions of dollars in damage and dozens of deaths statewide. Then came the 1997 to 98 event, still the benchmark that most Californians over a certain age remember most vividly. It delivered such a relentless, sustained parade of storms that NASA scientist Bill Patzert, who coined the nickname Godzilla El Nino for that specific winter, warned residents they'd essentially be kayaking in front of their own homes by January and February. That forecast proved accurate enough that the 1998 event alone caused 17 deaths and roughly $500 million in damage across the state. Then there was 2015 to 16, which, despite ranking among the strongest events ever measured in raw ocean temperature terms, broke that pattern in a genuinely unexpected way. It delivered nowhere near the rainfall that Northern California residents had been led to expect based on comparisons to 1997 and 98. That mismatch became an important lesson, one that scientists are now explicitly pointing back to as they caution against treating this year's record ocean temperatures as some kind of automatic guarantee of comparably extreme rainfall. This is exactly the context that brought nearly 6,000 people to log on to that virtual town hall organized by California State Senator Mike McGuire. On August 4th, that event was specifically convened to help residents across Northern California separate what McGuire described as hype from reality about what this winter might actually bring. And the panel of scientists assembled for that briefing did not downplay the concern. Daniel Swain, the climate scientist with UC Agriculture and Natural Resources, who has become one of the most closely followed voices on California extreme weather, told the audience directly that the system now gathering strength in the Pacific could produce, in his own words, an event we haven't seen before in living memory in California. Swain has spent years cataloging the state's floods, droughts, fires, and storms, and he does not reach for that kind of language casually. When a researcher with that specific body of comparative experience says a developing weather pattern could exceed everything in living memory, that's worth taking seriously, not as sensationalism, but as a genuinely informed assessment from someone whose entire career has been built around understanding exactly how unusual California's weather can get. To really understand why scientists are so focused on this specific event, and why it's genuinely different from the previous strong El Niños that Californians might remember, you have to understand the compounding factor that makes 2026 unlike 1997 or 2015 in a fundamental way. Every previous El Niño in the historical record developed against a cooler global baseline than the one we are sitting on right now. This year's event is forming on top of a planet where global ocean temperatures are already running warmer than at any point in recorded history, completely independent of El Niño. Swain has been explicit about why that combination matters so much, noting that scientists have never before observed a strong or very strong El Niño event arriving amid pre-existing global conditions this warm. Because of that, he said, it wouldn't be surprising to see genuinely unprecedented global impacts by later in 2026 into 2027, across flooding, drought, and wildfire-related extremes simultaneously. He's gone even further, suggesting that 2026, 2027, or both stand a real chance of setting new global temperature records, layering the naturally occurring heat redistribution of El Niño directly on top of a climate system that was already running hotter than ever before it even started. Now, let's get specific about California, because the abstract global framing, however alarming, doesn't tell you what actually shows up on your street, your beach, or your hillside this winter. The most immediate and most measurable impact that scientists have already quantified involves sea level, and it's worth understanding the actual mechanism here rather than just the headline number. El Niño doesn't just warm the surface of the Pacific. Warmer water physically expands, taking up more volume than the same amount of cooler water. And the weakened trade winds associated with El Niño allow that warm, expanded water to pile up against the west coast, rather than being pushed westward across the Pacific the way it normally would. The result, according to Swain speaking at the McGuire Town Hall, is a temporary sea level rise of roughly 6 inches along the California coast this year, specifically because of El Niño. That number becomes considerably more serious once you understand it isn't happening in isolation. Swain was explicit that this El Niño-driven 6 inches needs to be added directly on top of the sea level rise California has already experienced from long-term climate change, which, depending on exactly where you are along the coast, ranges from roughly 6 inches to a full foot accumulated over the past century alone. Stack those two numbers together, and communities across the California coastline are looking at total sea levels this winter, potentially a foot or more higher than what would have been considered a normal baseline just a generation ago, all concentrated into the exact same stretch of months when the state's biggest winter storms typically arrive. Mark Merrifield, director of the Center for Climate Change Impacts and Adaptation at the Scripps Institution of Oceanography, presented detailed modeling at the same town hall, specifically illustrating the increased likelihood of high wave events tied to this developing pattern. Higher baseline sea levels mean that even a routine winter storm surge, or a routine set of large waves, reaches meaningfully further inland and pushes seawater into infrastructure, storm drains, and low-lying neighborhoods that would have comfortably handled the same wave energy under normal conditions. This is precisely the mechanism behind the kind of dramatic coastal flooding and wave damage that made headlines in past strong El Nino winters. And Merrifield's presentation made clear that the elevated baseline this specific year is pushing that risk into genuinely new territory for many coastal communities. The rainfall question, somewhat counterintuitively, is actually the part of this forecast where scientists are being the most careful, and understanding why reveals something genuinely important about how El Nino science has evolved over the decades. For a long time, the working assumption for most Californians was simple: strong El Nino equals wet winter, full stop. The reality, as scientists at the McGuire Town Hall and elsewhere have been emphatic about clarifying, is considerably more nuanced than that. The mere existence of a super El Nino does not guarantee a parade of atmospheric rivers, those drenching narrow bands of concentrated tropical moisture responsible for a large share of California's rainfall and its most damaging flood events. Swain was direct on this point, explaining that an event this strong is going to significantly shift the odds in favor of a particularly wet winter, especially across Southern California, and likely Northern California as well for an event of this magnitude. But shifting the odds is fundamentally different from a guarantee. Dan Cahan, a researcher at Scripps, has made a similar point specifically about how the relationship between ocean conditions and actual rainfall has noticeably weakened over the current century compared to earlier decades. That's a genuinely unexpected wrinkle, one that's forcing scientists to broaden their forecasts and account for a wider range of possible outcomes, rather than confidently predicting a single straightforward wet winter the way older, simpler El Nino models once did. This uncertainty isn't a reason for reassurance, and researchers have been careful to frame it exactly that way. The 2015-16 Godzilla El Nino remains the clearest cautionary tale here. It ranked among the strongest El Nino events ever measured in terms of raw ocean temperature, and yet it largely failed to deliver the dramatic rainfall increase across Northern California that historical comparisons to 1997 and 98 had led many people to expect. What it did produce instead was a genuinely serious, if less anticipated, hazard. Record-breaking beach erosion up and down the California coastline, driven by the same combination of elevated sea levels and intensified wave energy that scientists are now flagging as a near certainty for this year's event, regardless of exactly how the rainfall forecast ultimately plays out. In other words, even in a scenario where the anticipated deluge of atmospheric rivers doesn't fully materialize the way older models might predict, the coastal flooding and erosion risk tied directly to sea level and wave energy remains a serious, largely unavoidable threat baked into the ocean physics of this event. There's also a genuinely significant marine ecosystem disruption already showing up as this El Nino builds, one that reaches well beyond simple weather impacts and into the coastal economy and food chains directly. El Nino disrupts the cold, nutrient-rich upwelling that normally sustains California's coastal marine ecosystem, and Chris Lowe, a marine biology professor and director of the Shark Lab at Long Beach State University, has described the resulting shift bluntly, calling it essentially a completely different ocean. Species like squid, anchovies, and sardines get pushed considerably further north than usual as the cold upwelling that normally concentrates them along the California coast weakens. Previous strong El Nino events have coincided with documented appearances of hammerhead, tiger, and bull sharks off California waters, species considerably more associated with warmer tropical conditions than California's typical coastal ecosystem. Past strong events have also produced serious documented harm to native seabird and marine mammal populations, including a record number of stranded Guadalupe fur seals and thousands of dead auklets and murres washing ashore along the west coast during the 2015-16 event. Casualties of an ecosystem suddenly starved of the cold, nutrient-dense water its food chain depends on. It's also worth understanding how the mechanics of El Nino actually reach California in the first place, because the connection isn't as simple as warm water in the tropical Pacific, somehow directly causing rain thousands of miles away. El Nino's warming reshapes atmospheric circulation on a genuinely global scale, weakening the trade winds that normally blow steadily east to west across the equatorial Pacific, and critically shifting the position of the Pacific jet stream, that high-altitude river of fast-moving air that steers storm systems across the entire west coast. Under normal conditions, the jet stream tends to sit further north, often directing the bulk of incoming Pacific storm energy toward the Pacific Northwest. During a strong El Nino, the jet stream typically shifts southward, pointing more directly at California in the southwest, which is the fundamental mechanism behind the storms and flooding rains a significant El Nino can deliver The genuine complexity researchers are still working through is exactly how reliably that jet stream shift translates into actual accumulated rainfall once it arrives, since the same broad southward shift can still produce meaningfully different outcomes on the ground depending on exactly how individual storm systems track, cluster, or fail to materialize within that generally favorable pattern. The financial stakes tied to this developing event are genuinely staggering when you zoom out to the global scale, even before accounting for California's specific coastal risks. Some economic analysis has flagged the potential for this El Niño to become the costliest on record, with the possibility of surpassing $5.5 trillion in global financial losses. That's a figure that would exceed the widespread flooding damage tied to the historic 1997-98 event, still considered one of the most economically destructive El Niño episodes ever documented. That kind of number reflects the genuinely global reach of this pattern, disrupting monsoon rainfall across Asia, shifting precipitation patterns across South America, altering hurricane formation across both the Atlantic and Pacific basins, and closer to home, threatening the UI, a specific combination of coastal flooding, erosion, and infrastructure strain that California's emergency planners are now racing to prepare for. That preparation is already visibly underway across the state, and it offers a genuinely useful window into how seriously officials are taking this specific forecast compared to a routine seasonal outlook. In San Diego, the city has convened a dedicated El Niño working group, bringing together representatives from every city department specifically to prepare for the range of weather-related emergencies this winter could bring, an effort officials describe as necessary precisely because the connection between ocean conditions and actual local rainfall has become less predictable in recent decades, forcing the city to plan for a wider range of scenarios rather than a single expected outcome. Officials have specifically flagged the need to closely monitor every creek, river, and lake across the region, from Santa Cruz up through Sorrento Valley and Lake Hodges, given that the city's stormwater infrastructure includes aging systems and century-old dams that weren't necessarily engineered with a compounding, climate-amplified El Niño event in mind. Further north, footage from Long Beach in late July already showed city workers building sandbags specifically to guard against flooding from high tides and strong surf, precautionary construction undertaken weeks before the El Niño pattern had even fully locked into place. A genuinely visible sign that coastal California isn't waiting for winter to arrive before starting to prepare. It's worth stepping back to understand why researchers keep returning to this specific combination of factors. Rising ocean temperature records, a warmer global baseline than any previous El Niño has formed against, and a weakening, less predictable relationship between ocean warmth and actual local rainfall, all treated as evidence that this event genuinely represents uncharted territory rather than simply a bigger version of a pattern California has weathered several times before. Super El Niño events themselves remain genuinely rare. As of early 2026, there have been only 5 documented in recorded history. Researchers studying long-term sea surface temperature variability have found evidence suggesting these extreme events may be becoming somewhat more frequent as natural variability increases against the backdrop of a warming planet, though the underlying science connecting long-term climate change directly to El Niño frequency remains an active, still developing area of research rather than a fully settled conclusion. Paul Roundy, an atmospheric scientist who has studied the specific question, has urged genuine caution about overinterpreting exactly what a record-breaking event like this one means for the years that follow, noting plainly that with only a handful of super El Niño events on record globally, the statistical foundation for confidently predicting long-term consequences remains genuinely limited. Scientists making projections based on such a small historical sample, he's argued, shouldn't claim excessive confidence about whether an event like this triggers a longer multi-year stretch of amplified global warming impacts, or whether its effects are considerably more contained to the single year or two immediately following the event itself. That's a genuinely important, honest caveat sitting underneath all of the more dramatic warnings. A reminder that even the scientists most convinced this event is unusually significant are being careful not to overstate exactly how far its consequences will ultimately extend. Beyond San Diego's coordinated response, similar preparation efforts have been quietly underway across coastal jurisdictions the length of the state, from harbor authorities reviewing dock and breakwater infrastructure, to county emergency managers updating flood evacuation planning for low-lying neighborhoods that haven't seen serious inundation risk since the last strong El Niño winter. Insurance industry analysts have also begun flagging this developing event as a genuine planning concern, given that California's coastal property insurance market was already under significant strain heading into 2026 following successive years of wildfire-driven losses, meaning a winter of serious coastal flooding and erosion damage would arrive at a moment when the state's insurance infrastructure has comparatively little slack left to absorb another major category of climate-driven loss. So what should residents across California actually take away from all of this, watching a super El Niño develop in genuinely unprecedented territory? The clearest, most consistently repeated message across every briefing, town hall, and official statement covered here is that the physical mechanisms driving coastal risk, elevated sea levels stacking on top of existing climate-driven sea level rise, and intensified wave energy layered on top of that elevated baseline are close to a near certainty this winter, regardless of exactly how the broader rainfall forecast ultimately plays out. The rainfall question carries genuine, honest uncertainty, shaped by a relationship between ocean temperature and actual local precipitation that has become measurably less predictable in recent decades. But the coastal flooding, erosion, and infrastructure strain tied directly to sea level and wave physics represents a threat California communities are already actively preparing for, precisely because the underlying ocean physics driving it don't carry nearly the same level of forecasting uncertainty that rainfall totals do. That's the real picture behind this developing Super El Niño, a climate pattern confirmed to be pushing into territory that has genuinely never appeared in 75 years of careful record keeping, arriving on top of a planet already running warmer than at any point in recorded history, and threatening California's coastline with a combination of elevated seas and intensified waves that scientists describe as close to guaranteed, layered on top of a rainfall forecast that remains genuinely uncertain in exactly the ways that matter most for flood planning. Nearly 6,000 people logged on to hear scientists explain this in plain terms because they understood correctly that this isn't a routine seasonal update. Stay with us as we keep tracking every new update from NOAA and from California's own climate researchers as this record-setting event continues developing through the fall and into winter. Because this is exactly the kind of story where the difference between being prepared and being caught off guard could come down to the weeks right in front of us.